Alright, physics students, today we are going to talk about constant acceleration formulas and graphs. Now if you remember, yesterday we talked about constant velocity situations, where the velocity was not changing. Today, however, the velocity is changing. Maybe it's increasing, maybe it's decreasing. Either way, we are going to be dealing with constant acceleration. So it could look something along those lines where velocity is decreasing, but the idea is that the velocity is changing at a constant rate, and that is called acceleration. And once again, just as a reminder, even though that very bottom line is slanted, we are dealing with one-dimensional motion only. In other words, things moving left to right, things moving up and down. That's it. Not flying through the air or going all sorts of different directions. At least not yet. Alright, so let's start with our definition of acceleration. The definition of acceleration is any time you have a change in velocity over time. Or, our good old Greek friend here, delta v over delta t. So let's expand that. What does delta mean anyway? Well, it means the change between the final and the initial. So v minus v naught over t minus t naught, just whatever the difference in the velocity is over the difference in the time. Now, consider the following. A situation when our initial time is 0, which makes everything real nice. And we will rewrite this formula. If you can remember, this is very similar to the process we used yesterday dealing with constant velocity formula. So we now have acceleration is v minus v naught over t minus 0, since t naught is 0. Or in other words, v minus v naught over t. And we're going to do some simplification of this formula here. Multiply both sides by t. Left-hand side we have at, right-hand side v minus v naught. Then we're going to add that v naught to both sides. So at plus v naught equals v. But then, of course, we would rather have that v all by itself on the left-hand side. So just switch it around. V equals at plus v naught, or final velocity of some object is equal to the acceleration of that object times the time, the final time, plus v naught, the initial velocity. We're going to carry this on over to the next slide. Just rewrite it nice and blue, a little bit easier. So, v equals at plus v naught, or blah equals blah blah plus blah. What does that remind you of? What does that remind you of? Blah equals blah blah plus blah. Having flashbacks here. Maybe. Y equals mx plus b. That is correct. This is a linear relationship. So let's draw a graph. Why not? We always do. If we look at the parallelism here, we find that the y on the y equals mx plus b corresponds to the final velocity. Okay, so that means that the y, which is the vertical axis, is going to be for the v. So the v is vertical axis, v in meters per second. The horizontal axis, which is normally x, is now t, so we'll put the units there, seconds. The y-intercept b is our v naught, and I'm just going to put a nice constant line there. It could go that is less slope or negative or whatever, who cares. And, I'm not so sure about this. Slope, well, let's do that slope formula. Rise over run. So that's going to be delta v, which is the rise, over delta t. Hey, I know that. That's the very definition of acceleration. Alright, how about that? Just to verify it here. So thus, on a velocity versus time graph, the slope is, wait for it, the object's, acceleration. Ta-da! Yes, hooray. So, before you get too confused, let's summarize the one fact from yesterday and the one fact from today. Wow, we're really speeding through this that we talked about. So, yesterday, on an x versus time graph, the slope is the velocity. on a velocity versus time graph, the slope is acceleration. I apologize for my poor handwriting. Just really need a lot of work on that, I guess. And welcome to your first AP formula. This is on your AP formula chart. In fact, it's the very first formula on the top left of that formula chart. You can find it. I recommend that you pull it out, recognize that you do. Make sure you can. And this is what their formula is. It's Vx equals Vx naught plus Axt. And you're like, we didn't have that. We had something very similar. We had V equals At plus V naught. So you can see they've just switched the V naught and the At, and then they've stuck an X on the end of practically everything, just to make sure that everybody knows, okay, this is talking about in one dimension. X. If we were talking about something moving up and down, vertically, we just put Y. Vy, so the final velocity in the Y direction is Vy naught, the velocity in the Y direction initially, plus the acceleration Y in the Y direction, and then times time. So just kind of switch those around, and we'll draw a happy face and declare ourselves finished. Thanks.